The discovery of Proxima Centauri b, a planet orbiting a star close to the Sun, was a major breakthrough in astronomy. At a distance of 4.2 light-years, Proxima b is in the habitable zone of its parent star, Proxima Centauri, which is part of the triple star system Alpha Centauri. Proxima b has excited the imaginations of scientists, space enthusiasts, and the general public because of its potential for life. But how does this distant world compare to Earth? Is Proxima b a relative of Earth, or is it something that could be an inhospitable world even though it looks like our own? As we explore Proxima b, it is important to understand the challenges and opportunities this planet presents for future space exploration. The concept of the habitable zone, the appearance of Proxima Centauri as a red dwarf star, the potential for strong ultraviolet radiation, and scientific instruments, such as the James Webb Space Telescope, allow us to study these distant objects. Everyone has a chance. Moreover, in this constant effort, the consequences of finding a life or a place of residence outside the world are profound, and our understanding of the world and the place of the world will change. People inside. Before going into the details of Proxima b, it is important to know the star it orbits, Proxima Centauri. Proxima Centauri is a red dwarf, a type of star smaller and cooler than our Sun. Red dwarfs are the most common type of star in the Milky Way and make up 70 to 80% of all stars. Despite their size, red dwarfs are not visible to the naked eye from Earth because they emit less light than stars like the Sun. Proxima Centauri is part of the Alpha Centauri star system, which consists of 3 stars: Alpha Centauri A, Alpha Centauri b, and Proxima Centauri. Alpha Centauri A and b are larger and brighter than Proxima, forming a binary star system, with Proxima orbiting the pair at a greater distance. Proxima Centauri's proximity to our solar system makes it a key target for astronomers looking to study nearby stars and their planetary systems. One of the wonders of Proxima Centauri is its existence. As a red dwarf, Proxima burns its hydrogen fuel at a faster rate than stars like the Sun, and has a lifetime of up to 1 trillion years, longer than 10 billion years. Longevity. A planet in the habitable zone of Proxima Centauri may have more time to develop life, if the conditions are right. However, red dwarfs such as Proxima Centauri are also known to oscillate. They are beneath the flames of stars that emit blasts of radiation capable of destroying the atmospheres of nearby planets. This poses a major challenge to the existence of planets such as Proxima b, which, as we can see, are exposed to dangerous levels of ultraviolet radiation. One of the main factors in determining whether a planet can support life is its position in the star. This zone, known as the habitable zone, is the distance from a star that is suitable for liquid water on the planet's surface. Liquid water is considered essential for life as we know it, making this habitable zone the focus of the search for Earth-like exoplanets. For Proxima Centauri, Proxima Centauri's orbit is closer to the star than the Sun's orbit to Earth, due to Proxima's smaller moon. Proxima b, with an orbital period of 112 days, is in this region and has the same amount of energy from the star as the Earth from the Sun. This proximity raises the intriguing possibility that Proxima b contains liquid water and is therefore potentially habitable. But being in a residential area does not mean living. A planet's atmosphere, geological activity, magnetic field, and other factors play a major role in determining whether life can exist. For example, Venus and Mars are in or near the Sun's orbit, but Venus is a fiery hell with a greenhouse effect, while Mars is a frozen desert with thin air. So, being in the right place doesn't mean the planet is like Earth. In the case of Proxima b, its close proximity to the star raises concerns about tidal locking, a phenomenon where one side of the planet faces the star while the other side is in the dark. Immediately, tidal locking can cause temperature differences between the day and night sides of the world, making the surface unstable. However, air circulation or ocean currents can help moderate these extreme temperatures, making them more common in some parts of the world. Proxima b is called Earth's cousin because of its size and location in the star's habitable zone. A rocky planet with a mass 1.17 times the mass of Earth, it is similar in composition to our own universe. The ability to have liquid water on the surface has strongly suggested that it can support life, microbes, and, in the best conditions, even complex life forms. Despite these advantages, however, it is not certain that Proxima b is as close to Earth as we might expect. One of the main concerns is the high levels of ultraviolet radiation that Proxima Centauri receives. Like a flaming star, Proxima Centauri emits powerful radiation bursts that can destroy the planet's atmosphere over time. Without a protective atmosphere, the planet's surface would be bombarded by harmful radiation, potentially rendering life unsustainable. Additionally, Proxima B may lack the magnetic field necessary to protect the atmosphere from stellar winds and radiation. On Earth, the magnetic field created by Earth's metallic iron core protects us from the sun's rays and allows life to survive. If the atmosphere of a planet, such as Venus, is too thick, it can trap heat and create a greenhouse effect, making the surface uninhabitable. Despite these challenges, scientists are optimistic about Proxima B's potential for habitation. Launching in 2021, the James Webb Space Telescope is an advanced instrument that can analyze the atmospheres of distant exoplanets by studying the light they emit or reflect. By viewing Proxima B in infrared light, the telescope can detect the presence of water vapor, carbon dioxide, and other gases that indicate the planet's ability to support life. The James Webb Space Telescope, JWST, is one of the most powerful instruments ever built by man to study distant planets, stars, and galaxies. Its ability to observe at infrared wavelengths is particularly useful in the study of exoplanets, such as Proxima B. Unlike visible light, it can be blocked or scattered by dust and wind, and infrared light can pass through these barriers, allowing binoculars to see what they can. Hide. One of JWST's primary goals is to study the atmospheres of planets by analyzing how the moon interacts with them. When a planet passes in front of its star, some of the star's moons go into the planet's atmosphere, if there is one. This light can be analyzed to determine the composition of the atmosphere, which provides important information about the world's weather, climate, and habitat. In the case of Proxima B, JWST can detect key molecules such as water vapor, carbon dioxide, methane, and oxygen, all of which are considered signs of life. The presence of these molecules indicates that Proxima B has gas and water on the surface. If these molecules are absent, it would indicate that Proxima B is more like Mars or Venus than Earth. JWST's infrared capabilities allow it to measure the planet's temperatures and other parameters related to their habitability. If Proxima B had a dense atmosphere, it would trap heat and create a greenhouse effect, similar to what we see on Venus. If the atmosphere is thin or absent, the Earth's temperature will fluctuate between day and night, making life less viable. The search for extraterrestrial life is fundamental to man's understanding of his place in the universe. If we see microscopic life on a planet like Proxima B, that would be a sign that life is not unique to the universe, that the universe is full of life. This discovery will revolutionize our understanding of biology, evolution, and the origin of life. But the search for life outside comes with challenges. Although Proxima B has the right conditions for life, it may be difficult to see from a distance. Most methods used to study exoplanets rely on indirect measurements, such as analyzing light from a host star that has exited the planet's atmosphere. These measurements can provide important indications, but they are not necessarily life-saving indicators. Also, life on other planets is very different from Earth. While we often look for the features of Earth, water, air, and mild temperatures, life exists in extreme environments, such as under the ice of the frozen moon or in the deep high-pressure atmosphere of the atmosphere. Discovering life in these environments requires very different discovery methods. Even if no life is found on Proxima B, the search for habitable exoplanets is still an important task. By studying these distant worlds, we can learn more about what makes planets suitable for life and help us better understand the history of the universe and its future. The discovery of habitable planets like Proxima B also raises ethical and philosophical questions about the future of human space exploration. Although the James Webb Space Telescope and other observatories are providing valuable information about distant planets, they cannot answer all of our questions. To fully understand Proxima B and its potential for life, we need to send a mission to the planet. However, traveling to another star is a huge challenge that is beyond our current technological capabilities. Currently, the fastest spacecraft ever built, NASA's Parker Solar Probe, is traveling at 700,000 kilometers per hour, 430,000 miles per hour. Despite this incredible speed, it will take more than 6,000 years to reach Proxima Centauri. Clearly, if we were to send spacecraft to other star systems within human lifetimes, we would need new methods of propulsion. One promising technology is the solar launch concept, which uses the sun's pressure to propel a spacecraft. This method, first proposed by the scientist Carl Sagan in the 1970s, has received attention in recent years due to advances in materials science and small. The Breakthrough Starshot project, funded by Russian entrepreneur Yuri Milner, is building a small, light solar-powered spacecraft that can travel up to 20% of the speed of the Moon, using powerful lasers. These spacecraft, called starships, could reach Proxima Centauri in just 20 years. While the idea of sending research to another star system is exciting, there are many challenges to overcome. Starships must survive the harsh conditions of interstellar space, including collisions with dust and atmospheric radiation. It will also be difficult to communicate with Dad because of the great distance. Even at 20% the speed of the Moon, it takes more than 4 years for a signal from Proxima Centauri to reach Earth. In addition to the technical challenges, there are also ethical questions to consider. If we find that Proxima B is habitable or habitable, should we send humans to Earth? What are the rights of citizens and how to work with them? The prospect of humans becoming an interstellar species raises ethical and philosophical questions that must be addressed as we move closer to reaching other planets. The discovery of Proxima B and other planets brings us closer to answering one of humanity's oldest questions. Are we alone in the universe? While the challenges of studying and traveling to distant planets are great, the rewards can be just as great. Proxima B shows what's possible, a rocky planet inside. The discovery of another Earth-like planet would be one of the most significant scientific achievements in history, reshaping our understanding of the universe and our place within it. Whether Proxima B is a barren rock or a thriving world, it serves as a reminder of the vastness of the cosmos and the endless possibilities that lie beyond our solar system. The quest to find a second Earth is only just beginning, and Proxima B is at the forefront of that journey.